So here I'd like to transition to Elvira, really that showcases a little bit how efficiency can be enhanced on the customer side for compressors. So please.
Thank you, Dimitris. I would like to highlight, so I'm going to talk about the compressed air systems efficiency. So it's not a compressed air as a service, but it's efficiency of compressed air systems. And I just would like to guide our audience a little bit into the problematic of this, because when we look at the industrial plant, we have there various machines and production lines. Each of these machine and production lines, they have instruments, and those instruments, they're actually using compressed air for various operations. So whenever you see any blow-on applications, press applications, actually compressed air is the most expensive source of mechanical energy in industry. And it's not so easy just to say, okay, let's do the generation part and do something on the compressor side. First, we should reduce on the instrument side and the production line, and then adjust the generation. So what is logical, right? It's very important topic because it's used in various types of industries, from food to cement, automotive, and pharma. And compressed air nowadays is accounted for 20% of the overall electrical consumption in industrial sector. So it's very big chunk of this. Good news, and surprisingly, actually almost 60% of this can be reduced thanks to some measures. So 10% that we usually look now, we call it a fragmented measure. So we either do something with the compressor room, we do something with a little bit with leaks, maybe we repair tubing, but other 50% can be really decreased just because we use the efficiency improvement at each single place. So from the generation, from the distribution to the generation, and that we take efficiency holistically. This is why energy efficiency of compressed air systems, and not just of the compressor room, becomes extremely important, extremely promising, but at the same time, a very complex topic. So it's exactly the same thing if we look in the household, if we look in the cooling or heating as a service. So we need to always take a look at the efficient design, efficient technology that we use, and energy saving habits, as we say, and audits. So best practice and audits. When we take those measures fragmentally, for example, we use efficient technology, and here is just an example of a Moroccan steel manufacturer. They bought a new efficient machine for their production, for the operation, and the compressor started to produce, had to produce more, or 25%. So you think it might be crazy, but actually compressed air system was not designed to handle this inefficient component, this inefficient machine. So this is why it started to had to produce more. Similar things might happen also on the audit side. Again, when we do only audits and we provide roadmap for the factories here, for example, one example in the past 5 years, compressed air audits of 13 factory, 13 cement plants was done, and good opportunities were found. 5 years later, 4 systems were worse, 4 were the same level. So they implemented something, but it's again went worse. But 3 of them and just 2 of them were really had an exceptional savings. So they really took audits seriously. So this is why it's extremely important to have the holistic approach on this. So when we look at this, we always focus on the linear supply chain, right? So we have this fragmented industry with various components, various stakeholders there. We have auditors, we have equipment suppliers. For them, efficiency is not priority. So they don't pay for the energy bill. And more efficient components they supply in the market, higher the prices, right? So they have to find this balance so to be still compatible on the market. This is why there are many efficient solutions that are available on each single step, but it's usually for them hard to sell. Auditors and engineers, efficiency for them, of course, is important, but in terms of price, it's again not relevant, so they don't pay for this. So because auditors is usually a smaller companies that do the performance audits. And of course, for industrial plant, this is people that struggle the most. So they pay a lot of money for their energy bills, and efficiency for them in the priority. So coming to the efficiency as a service, we need always to look, as my colleagues here in the panel said before, in the win-win situation for the equipment suppliers, auditors, and industrial plants. It's, of course, all of them have their pluses, that's quite obvious. But the biggest thing and the biggest problem that I witnessed in the past 13 years working in the industry, it's high risk. And risk for them, it's uncertainty. So I call it efficiency uncertainty curve. So higher the energy efficiency performance is, harder it is for factories to implement it. So they have just a fear of implementing new efficient solution, new efficient design or approach or any other things. And it's basically based on the, it has a few things. It has the integration of the ISO standards that might be also quite complex, policy integrations that there are not so many in our field, efficient technologies, again, they exist on the market, but they're not widely implemented. It's not the best practice. Expertise, so we have, of course, experts, but it's not that everyone who does the audits can actually handle complex solutions. Behavioral change, compressed air is usually something people say it's inefficient, so it's not it's something like dirty, we need like to take care of this, and air doesn't cost anything, they actually don't get a bill for the compressed cost. And of course digitalization, so how to connect all of these various parts in one system. Of course our objective is to lower this curve, and when we think about the successful project, so I will not go into the details, but I just want to show how complex it and how many stakeholders there are, right? So we start with the preliminary analysis first. And in the preliminary analysis, basically have the just ideas of how much opportunity factory has to save. Then we have a detailed analysis. In the detailed analysis, in Direktin, we developed the software, we developed the platform, a software solution that actually includes all the stakeholders and the steps for those energy efficiency project as a service. So we do the modeling, and working together with auditors that collect the data, we already can create the roadmap of which kind of equipment it's required, which kind of a design is required, what are the changes has to be done to have a better energy efficiency, better efficiency performance of that system. So then we go into the part where there is the financial institutions come in. So either the customer can finance it themselves, or there is, Florian said before, that there are many also companies that actually do this as a business, the financial part. And then we have implementation part with the contractors. So, and then contractors that are in the system, so they go and perform the work. And then the most important part, of course, it's the monitoring. So monitoring has to be done after the implementation and the preliminary analysis, so we can establish a new baseline. And this is where the money comes from. So this is where the savings are coming from, and basically each stakeholder from this supply chain shares those savings at a certain percentage regarding their work. So it is a win-win-win-win situation for the contractor, auditor, platform, financier, and the end user, because end user gets then pays after the project is fully implemented and he actually has the first savings. So he gets a bill lower with the lower consumption. So after this, of course, there is also decision support system that helps to provide the predictive maintenance for the compressed air systems, so that they don't pay more and they can purchase easier the equipment. And another point that we also will be working on in the future is the blockchain to control the energy efficiency savings, and to be able also to have a carbon credit based on the blockchain, but not on the physical certificates, but on the smart contracts that will allow this ecosystem. So as you can see, I think there are usually like the questions, right? Why we need the energy efficiency as a service? Because for one company, it's very hard to get all this project done, to have involved all the customers there, all the stakeholders. And in general, energy efficiency projects are actually very very expensive at the beginning for the end user. So, but then this is why we developed a software application where the customer first can design and understand what are the opportunities for this, check what are the suppliers in their region, who are the contractors or auditors, the portal for the auditors with the various solutions and trainings where actually you can connect with experts. And these experts include the ecosystem of the end customers, of database and service providers. So basically, we have the software as a service that serves to the stake of the energy efficiency as a service connecting it. In terms of the payback period, I think this is an important thing just to show you a couple of examples. Up to 30, usually it's around 30% of energy savings per year, even though it can be also 60%, depending on the state of the system, depending also how much there is investment and ROI, but ROI is usually below 1 year, so it can be 1.5 year maximum or 2 years. But here, for example, we have savings for petrochemical was 32% and ROI 11 months, or for woodworking manufacturers, so furniture manufacturers, so it's ROI below 1 year for 27%. So it's kind of like no-brainer, but I think the complexity of the implementation of energy efficiency in compressed air systems should be solved at some extent.